Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 8, 2025, just yesterday. It presents a new reinforcement learning framework that trained a 32 billion parameter model to outperform even GPT-4o on mobile app navigation tasks. The paper is titled MobileGUI-RL, Advancing Mobile GUI Agent Through Reinforcement Learning in Online Environment, 2507.05720 version 1, and their approach to solving the tricky problem of online learning is quite sophisticated. The core idea is to move away from offline training on static data, and instead train agents directly in a live environment, using some clever techniques to generate tasks and rewards. Alright, this first figure really visualizes their clever two-part framework. The top part, called task creation, is all about generating training data. First, an agent performs self-exploration, just randomly tapping around the phone's graphical user interface. Then, an LLM looks at these paths and creates natural language tasks, like find the fastest route to Napa. Finally, these tasks are filtered to remove any that are impossible or unclear. The bottom part then shows the model training, where the agent attempts these good tasks over and over, receiving rewards that help update its internal strategy or policy to get better. Building on that training loop, this table details the agent's action space, which is just the set of possible moves it can make on the phone. You see the basics here: click, swipe, type, and hitting system buttons like back. The agent also learns when to wait or when to end the task. To learn the best sequence of these actions, the researchers adapt an algorithm called Group Relative Policy Optimization. This is a method for updating the agent's strategy by comparing how well different action sequences or trajectories perform against each other. Okay, so how well does this whole strategy actually perform? This table lays out the results. It compares their models against others, like GPT-4o, across 3 different mobile benchmarks. The key metric here is success rate, or SR, which is just the percentage of tasks the agent completes correctly, and the results are really striking. On the Android World benchmark, their MobileGUI-32B model achieves a 44.8% success rate, decisively outperforming GPT-4o's 34.5%. This really validates their online reinforcement learning approach. So, building on those impressive numbers, this next table digs into why the model works so well. It's what's called an ablation study, where researchers systematically remove parts of their system to see how performance is affected. For their 32B model, you can see that removing curriculum learning, which is the strategy of starting with easy tasks and getting harder, causes a massive drop in the success rate, from 44.8% down to 34%. Removing the decaying reward, which encourages efficiency, also hurts performance significantly. This really proves each part of the framework is crucial. Okay, so here we get a really clear case study, a before and after look at the agent's performance. The task is to create a calendar event with a specific title, description, and time. On the left, you see the agent's attempt before reinforcement learning. It gets the title right, but it completely misses the meeting description and fails to set the event's end time. But then, on the right, after training, it executes flawlessly. It navigates, types the description, and correctly sets both the start and end times. This really drives home how the training refines the agent's ability to handle complex, multi-step instructions. So to wrap things up, that calendar example really shows the power of this approach. The key takeaway is that by training the agent directly in a live environment, using a curriculum of automatically generated tasks, the researchers have created a system that learns and adapts in real time. This method allows the agent to become incredibly proficient, even outperforming much larger models like GPT-4o. It's a significant step forward for creating truly helpful agents that can navigate our complex mobile apps. That's all for this week's AI Research Roundup. Thanks for tuning in.